Hey everybody, I'm going to do pages 5 and 6 right now because there's just 2 questions on this first page here, page 5. So it says, which elements are present in this mixture? So that means they're talking about the spectrum here. And I know that all of the bands of a particular line or of a particular element must be present or it's not there. So first I see this one looks like it's there. This one looks like it's there. Looks like it's there. Yep. And yep, so I'm thinking element X is in there. I'm looking at Z. I'm missing a band right here. So since there's no band right there, element Z cannot be in there. Element D, Z's only got this double band here, and I do not see that double band here, so element D is not in there. Element A, that looks pretty good. This one looks good. And I'm not really sure about this one and this one, but they look like they definitely could be there. So I'm saying it's element A and element X. That's how we do this. Okay. And it says each line in the spectra represents the energy. Okay, so now we have to remember what is an excited electron. So we have a nucleus and we have our energy levels. And we have an electron here. What happens is I add energy and the electron gets excited and jumps up, and then it falls back down and gives off the energy that it absorbed in the form of light. So this spectra is, let's make sure it's the right spectra, bright line spectra. Okay, it's not absorption, it's bright line spectra. So it is definitely going to be released. It's not absorbed. This is the light that I'm seeing that comes off when it falls back to ground. Okay, so the energy released when an electron moves from a lower to a higher energy state, that doesn't make sense. Energy is absorbed to make it jump up. So 3 doesn't make any sense. Correct answer is 4. The energy that is released when an electron moves from a higher energy state, which is up here, down to there. That's when they give off light. That question is going to be asked in one way or another on your test this year. You need to know the basics so you can put it into motion however they represent this question to you. And that's all of page 5. We're going to move right on to page 6. Table below shows the number of protons, neutrons, and electrons for 4 ions. Which ion has a charge of -2? Okay, so I look at that -2. I say negative is definitely the charge on electrons, and electrons are winning by how many? 2. So who has electrons winning by 2? And right off the bat, I see it's A. Because here I have 8 protons and I have 10 electrons. Electrons are winning by 2. In E, the charge is -1. In G, the charge is +1 because protons are winning. And in J, protons are winning by 2, so it's a +2. Notice I didn't talk anything about neutrons because we know that neutrons are neutral. Okay, they don't have charge, they only have mass. What is the approximate mass of an atom that contains 26 protons, 26 electrons, and 19 neutrons? We know that electrons don't have mass, so I just say 26 plus 19. 26 plus 19 is 45. The U means atomic mass units. Okay, 35. Which electron configuration represents potassium, which is element K, in an excited state? So first thing I need to do is go to the reference table and find me K. Then I can go from there. I need to find out how many electrons it has and what its ground state configuration is. So element 19 is K, and it's got a 2, 8, 8, 1 for my ground state. This is what I see on the periodic table. So right off the bat, I know 3 is not right because that is the ground state. Okay, and when I add these up, I see that I have a total of 19 electrons. And I know that the total has to be the same because if I gain or lose an electron, then I'm an ion, not an excited atom. Okay, because excited atom, that key word right there, same numbers of protons and electrons. So I can't lose those electrons. So in number 1, I have 15 electrons. So that's not 19, so 1 ain't right. And 2 has 15 electrons, so that's not right. And why did they do that? Oh, because they did element P, phosphorus, with 15, and you had to know that potassium is K, number 1, and they gave you 2 wrong answers for element P, phosphorus. And definition of an excited electron or an excited atom is when one from an inner kernel shell jumps up, and so 2, 8, 7, 2 does also equal 19, and that represents one from the third shell jumping up to the fourth shell. There is my excited electron configuration, specifically of potassium. Oh, here we go, and now another potassium 42. So we're keeping right with potassium. What is the total number of neutrons in an atom? Well, I know that neutrons have mass, and I know protons have mass. Add them up, that's where I get my mass number, which is 42. You've got to know that K42 is telling me it's an isotope with a mass of 42. When I look at the periodic table, I see potassium normally has a mass of 39. So one of these answers is going to be based on you using the mass 39 and not 42. So I'm going to take this total mass of 42, and I see potassium has 19 protons because it has an atomic number of 19. And I am going to just subtract those two numbers and type this into my handy dandy calculator because I do not want to mess something up like this. It's so simple. 42 minus 19 gives me 23. And I bet 39 minus 19 is 20, and the most common wrong answer to this is going to be number 2, because then you used the actual mass on the periodic table instead of using the mass 42, which is the isotope this one's talking about. All right, given the equation representing this reaction, what is the total number of moles of carbon that must completely react to produce 2 moles of C2H4, okay, or H6. So I noticed that this is a 1 here. And if I want to produce 2 moles of it, what do I have to do to the equation? Double the whole thing. So if I double this whole thing, then the 4 carbon would become 4, hydrogen would become 6, and the C2H6, which is 2 carbons, is that's ethane, by the way, gets me up to my 2. So now what's the number in front of C when I multiply everything by 2? That's 4. This is a moles and stoich question. 38, and we're done with this video. Which type of chemical reaction is represented by this equation? Well, I have an Mg, single element, and a compound. And then, oh, look, the Mg is over here, and didn't it switch with the H? I have one element switching out. That's definition, single replacement. It's not a synthesis. Synthesis is 2 things forming one thing. I definitely don't have one thing at the other side. Decomposition is 1 thing breaking apart into 2 things. I don't have that. And it's not a double replacement because then this Mg would need to be bonded to something other than Cl, like, I don't know, oxygen or fluorine. I mean, if this was bromine here, and then this became hydrogen bromide, then it would be a double replacement reaction, but I had a single element here. Single element here, single element here tells me single replacement. And that wraps up pages 5 and 6. Keep working, guys.